The aluminum can industry is a whirlwind of activity, cranking out a staggering 200 billion cans every year, nearly 550 million every single day. Seriously, that's enough to build a tower of cans from here to the moon and back. But here's where it gets even more intriguing. More than 75% of this colossal output is whisked away to recycling centers rather than ending up in landfills. You see, the secret of aluminum lies in its unique properties. This metal is incredibly lightweight, yet remarkably durable, and possesses a rare ability. It's infinitely recyclable without losing a trace of its quality. Plus, recycling aluminum saves up to 95% of the energy needed to produce new cans from raw materials. With recycling contributing billions to the economy annually and creating jobs, it's clear that turning old cans into new ones is more than just a nifty trick, it's an economic powerhouse. So, join us as we dive into the fascinating process of transforming old aluminum cans into new ones. Step 1. Collection. The journey of recycling aluminum cans begins with the simple act of collection. Every time you finish a soda or beer and drop that empty can into a recycling bin, you're initiating the first critical step in the aluminum recycling process. Across the US, for example, this small action is repeated millions of times each day, contributing to an impressive recycling rate of around 70% as of 2023. Collection happens in several ways. In many communities, curbside recycling programs allow households to conveniently recycle cans by placing them in designated bins, which are then picked up by recycling trucks. These trucks transport the cans to materials recovery facilities, or MRFs, where they are prepared for the next steps in the recycling process. In addition to curbside programs, buyback centers and deposit programs also play significant roles in the collection phase. In states with container deposit laws, consumers can return their empty cans to designated locations and receive a small refund, typically 5 or 10 cents per can. This incentive has proven effective in boosting recycling rates, as it encourages people to return their cans rather than discard them. Step 2. Sorting. At the MRF, the aluminum cans undergo sorting to separate the aluminum from other materials. Sorting is crucial because it ensures that only aluminum moves forward in the recycling process, maximizing the efficiency and quality of the final product. At this facility, cans are first passed through various automated systems designed to identify and separate materials. One of the key technologies used is the eddy current separator. This machine uses a powerful magnetic field to repel non-ferrous metals like aluminum, causing the cans to jump off the conveyor belt into a separate collection area. This method is highly effective in isolating aluminum from other recyclables, such as plastics, glass, or steel. In some cases, manual sorting is also employed, where workers remove any contaminants that the machines might have missed. Ensuring the purity of the aluminum stream is essential because any contamination can affect the quality of the recycled aluminum and complicate the subsequent processing steps. Once sorted, the clean aluminum-only batches are prepared for the next stage. Step 3. Shredding. Once the aluminum cans have been sorted and separated, they move on to the shredding phase. This step involves breaking down the cans into small, uniform pieces called shreds. Shredding serves multiple important purposes in the recycling process. First, shredding increases the surface area of the aluminum, which makes it easier to remove any coatings or contaminants that might still be attached, such as paint or plastic labels. These coatings are often made of materials that wouldn't melt properly during the smelting process, so they must be dealt with early on. The shredding process prepares the aluminum for more efficient cleaning and subsequent melting. Secondly, shredded aluminum is more manageable and easier to transport. Smaller pieces take up less space and can be packed more densely, which reduces transportation costs and makes the recycling process more economical. Shredding also plays a crucial role in improving the overall efficiency of the recycling process. Smaller pieces of aluminum melt faster and more uniformly in the furnace, which conserves energy and reduces the time required for melting. Step 4. Melting. After the aluminum cans have been shredded into smaller pieces, the next step is to melt them down. The shredded aluminum is fed into a high-temperature furnace that heats the material to around 1220 degrees Fahrenheit, equivalent to 660 degrees Celsius, the melting point of aluminum. This process transforms the solid aluminum shreds into a molten liquid state, making it easier to purify and cast into new shapes. Melting aluminum is highly efficient because aluminum is a metal that can be recycled indefinitely without losing its quality. In fact, recycling aluminum requires only about 5% of the energy needed to produce new aluminum from raw materials, such as bauxite ore. This energy savings is significant, especially when considering that recycling a single aluminum can saves enough energy to power a television for 3 hours. The melting process also plays a crucial role in conserving resources and reducing environmental impact. By recycling aluminum instead of mining and refining new material, we can reduce greenhouse gas emissions and minimize the need for environmentally damaging extraction processes. Once the aluminum is fully melted, it's ready for the next steps: purification and casting, which will prepare it for its transformation into new products. Step 5. Purification. Once the aluminum has been melted down into a liquid state, it undergoes a critical purification process. This step ensures that the molten aluminum is free from impurities, which is essential for producing high-quality recycled aluminum. During the melting process, contaminants like paint, coatings, or even small bits of other metals might still be present in the liquid aluminum. To remove these impurities, a process called fluxing is used. In fluxing, a mixture of gases or salts is introduced into the molten aluminum, causing impurities to either float to the surface or combine with the flux material. These unwanted materials are then skimmed off, leaving behind purer aluminum. Additionally, degassing might be employed to remove any dissolved gases, such as hydrogen, which can create unwanted porosity in the final product. Degassing is typically done by bubbling an inert gas, like argon, through the molten aluminum, which helps to remove trapped gases. This purified molten aluminum is now of high enough quality to be cast into new forms. Step 6. Casting. After the aluminum has been purified, it's ready for the casting process, where the molten metal is formed into solid shapes that can be used in manufacturing. The purified liquid aluminum is typically cast into large blocks, known as ingots, or rolled into sheets, depending on its intended use. For aluminum cans, the most common form is casting into ingots. These ingots are massive, often weighing up to 30,000 pounds, and serve as the raw material for producing various aluminum products. The ingots are cooled and solidified under controlled conditions to ensure they have a consistent internal structure, which is crucial for the durability and quality of the final products. In some cases, the molten aluminum is directly cast into thin sheets that will be used to manufacture new cans. These sheets are typically about 1/10 of an inch thick and are rolled and processed further to achieve the desired thickness and properties for can production. Casting is a pivotal step because it transitions the recycled aluminum from a liquid state back into a solid form that can be efficiently processed and shaped into new products. Step 7. Rolling. After the aluminum has been cast into ingots or sheets, it moves on to the rolling process, where it's thinned out to the precise thickness required for making new cans. This process involves passing the aluminum sheets through a series of powerful rolling mills, which apply enormous pressure to flatten and elongate the material. Initially, the aluminum sheets, which are 1/10 of an inch thick, pass through the rolling mills multiple times, gradually reducing their thickness to about 0.01 inches, roughly the thickness of a sheet of paper. Rolling is performed at both hot and cold temperatures, depending on the specific requirements of the material. Hot rolling, done at temperatures above the metal's recrystallization point, helps improve the metal's ductility, while cold rolling at lower temperatures increases its strength and smoothness. The rolled aluminum is then coiled up for easy transportation to can manufacturing plants. The final product is a thin, flexible, and highly durable aluminum sheet, ready to be shaped into new cans. Step 8. Shaping. In the final step, the rolled aluminum sheets are transformed into new cans through a precise shaping process. The aluminum sheets, now thin and flexible, are fed into high-speed machines that cut them into small discs. These discs are then formed into cylindrical shapes using a process called drawing and ironing. In this process, the aluminum disc is first drawn into a shallow cup shape. Then, the cup is ironed out, passing through a series of rings that stretch and thin the walls to create the can's familiar cylindrical shape with a smooth surface. The bottom of the can is formed to be slightly concave, which adds strength and stability to the structure. After shaping, the cans are trimmed to the correct height and undergo a series of inspections to ensure they meet strict quality standards. They are then washed, sterilized, and ready for decoration. Labels, logos, and designs are printed directly onto the cans using specialized printing machines, preparing them for branding. And finally, the cans are sent to beverage companies where they are filled, sealed with lids, and packaged for distribution. This entire cycle, from old can to new, can take as little as 60 days, making aluminum recycling an efficient and sustainable process. So, the next time you crack open a cold drink, remember that your can might have already been part of someone else's refreshment just a couple of months ago.